Hello everyone, welcome back to a new video. So we left something in the first section, which is that when we are dealing with waves, we are treating them as rays. So according to Huygens principle, each point on a wave front acts like a tiny source, creating small waves. And by combining these waves, we will find a new wave front. This is basically what Huygens principle is. But instead of dealing with this complicated principle, we're going to have a simpler way of dealing with waves. We're going to treat them as straight lines or as rays. As you see here, this is a source of light, and you have a straight line. This is what we are calling rays. Something else you should know here is that intensity of light is inversely or follows the inverse square law, 1 over distance squared. So imagine you have two objects. We have a question like this in the section review. Imagine you have, let's say this one, the source of light. You have this source of light, and there is a distance to this. If you triple that distance, or if you double that distance, we're going to say 1 over d squared is equal to what? Of course, we have intensity of light. This is intensity of light is 1 over d squared. If we double that distance, we're going to say 1 over 2 squared. This is going to be 1 over 4. If we triple that distance, it's going to be 1 over 3 squared. It's going to be 1 over 9. This is the fraction, or this is the change in the intensity of light. We have section review. Identify which portions of the electromagnetic wave spectrum are used in each of the following devices. You have a microwave oven, it follows. It is microwaves. You have a single lens reflex camera, it is visible light. A television set is what is radio waves. If an electromagnetic wave has a frequency of 7.57 times 10 to the power of 14. So we have what? We have frequency, which is equal to 7.57 times 10 to the power of 14 hertz. What is the wavelength? Wavelength is equal to what? And what part of the spectrum is this? So let's find the wavelength. Remember that c was equal to frequency multiplied by lambda. Then if you want to find lambda, lambda is going to be c divided by frequency. C is the speed of light, 3 times 10 to the power of 8, divided by frequency, which is equal to 7.57 times 10 to the power of 14. What is going to be the result? The result, lambda, is going to be 3.96 times 10 to the power of minus 7 meter. To what part of spectrum is this? This is going to be 396 Newton meter, if we change that to Newton. So this is going to be what? This is going to be ultraviolet spectrum. Question 3. Galileo performed an experiment to measure the speed of light by timing how long it took light to travel from a lamp he was holding to an assistant about 1.7 kilometers away and back again. Why Galileo was not able to conclude that light had a finite speed? Because light travels very fast, and this distance is too short to calculate the speed of light. 1.5 kilometers is really short when we are dealing with the speed of light. Imagine light is going 300,000 kilometers per second. So this is really fast. Having a distance of 1.5 kilometers is going to be really difficult to notice or calculate the speed of light. Question 4, how bright would the sun appear? Look at this one. We just talked about the intensity of light. How would the sun appear to be to an observer on Earth if the sun were 4 times, so we have what? 4 times farther from Earth than it is. So we have intensity of light. Express your answer as a fraction of the sun's brightness on Earth's surface. Intensity of light is equal to 1 over d squared. We have 4 times, so this is going to be what? intensity is equal to 1 over 4 squared. So we have 1 over 16. So this is the fraction of the brightness of the sun. This is it for today. In the next lesson, we'll be starting section 2. See you in the next video.